Okay, welcome to CIS 285 video lecture, chapter 6, methods, or what they call modularizing your code with methods. Now, some of this is just a primer for those of you who've had the CIS 150 logic class, so I'm going to address some beginning topics that you probably remember or maybe you've forgotten. So what I have here is a little application that grabs the length and the width and then calculates the area. So if I go to the code here, we can see that this is the button calculate event, click event handler. So I'm grabbing the text the user puts into the text box, and we're making some assumptions here. This is a simple application where I'm not even validating the data to see if it can be converted to a number. We're going to make the assumption that it's a valid number. So I have three variable declarations, and all I'm doing here is I'm just pulling this out and initializing these variables within this declaration at the same time, just to save a couple of lines of code. We have three variables. This should be DBL area. I'm sorry about that. That's what it should be, if I'm going to follow the correct naming convention along with the others. And this would be DBL area. And this would be DBL area. Go ahead and fix all this so I don't have to keep going. All right. Excuse me. You're probably asking yourself, well, my goodness, why did you modularize this code? Why did you put it in a method? Well, for one thing, that's what we're doing in chapter 6. But you would have a valid point if you said, well, it's just multiply length times width. There's your area. Why would you want to do that? Well, there's something called polymorphism in these object-oriented languages. And this is one of them. You can have multiple instances of the same method with the same name, as the only requirement here is that the number and excuse me, type of arguments differ from one to the next. And when they do, and you call them, it gives you enormous flexibility, because I could have a calculation engine that calculates area for rectangles, circles, triangles, all sorts of different odd shapes, three-dimensional shapes. That would be volume. So I could have a calculate area method that would calculate each one of those and put it all in one class. So there is a little bit of method to the madness here, and you'll see that, no pun intended. You'll see that as we get into classes. But for now, just sort of take my word for it. Now, there are two types of methods. There is the value returning method, and there is the void, or the non-value returning method. And I've got both of them in here, and we're going to take a look at that. Now, this is what's called the formal parameters list, or the argument list, depending on which book you're reading. So what happens here, in order to call this method, which I will get to in a minute, it takes two arguments, length and width. That's strictly up to you. It can take no arguments, like if it's just going to output something. But you still have to have the opening and the closing parentheses here. All right, that's one of the requirements. If you've declared this down here, and I have this where I can collapse it and get out of the way, this is the value returning version of that. If I declare this as a double and a double, two arguments separated by commas, then when I pass something in, that has to match in the number and the type. Double length, double width. They don't have to be the same name, because by default, when you pass an argument into a method, it's just taking the value stored at these locations and making a copy, sticking it in here, doing what it's going to do, and then returning the value. These are not the same variables as these. They're totally different. That's the default. That's called passing by value. They're simply temporary copies. I can do anything that I want to these arguments here inside of this method, and it won't change the initial values here, because they're temporary copies. Now, when I say temporary, I mean that I also do not have access to these arguments within my calling method, which is button calculate click, because they don't exist until this thing is called. And when it's called, execution in this area, in this line block of code, is temporarily suspended or put in suspended animation until this code runs, and then it comes back. So unless I do something different, I can't change the values here within the method, nor can I change the values of the method within the calling area. They're totally exclusive, mutually exclusive. And just remember, they're copies, and I'll show you that in a minute. Okay, so what goes on when I call a value returning method? Well, there's something right here you should remember called the assignment operator. Alrighty. How do you change the value of any variable memory location? With the assignment operator. If I want to change the value that is here in double area from 0 to 10, I could easily just say double area assignment 10, 0.0, semicolon. Well, that's what's happening here. Now, what is the other rule of an assignment operation? Well, first of all, it takes what's on the right over here and puts it in the memory location pointed to by the name on the left. That's what the assignment does. We call it the equal operator, but it's really an assignment in this case, not a test for equality. Well, you have to have only one value over here before that can take place. If there's math, any other kind of logical comparisons, whatever, all that has to come down to one value before the assignment can take place, right? That's what makes this work so well. Do I have one value over here? No, I do not. I don't have any value over here yet. So what's going to happen is this will get actuated or called. Execution will pause here. It will take a copy of what's stored at double length and double width, DBL width, pass those in. Execution will jump down to this implementation, which is the value returning version, and it will create these two little local variables, which are local to the, actually in the argument list, to this method. It will pass copies of what's stored here, and I'll do whatever, and then the return statement sends it back. Now, this is the access specifier. You see this on your event handlers. There's public. This has to do with classes, really. Is it private to the class? Is it public to the class? Is it shared? There's a bunch of different ones. But mainly you'll see public and private. And this just means only members of this form here, or button object, can see it, or the form actually. Okay? So, in the header of a method declaration, you have an access specifier, which is, in this case, is private. And that has to do with security, to keep other objects from accidentally getting a hold of things they don't need. And this gets into object-oriented design methodology, which we'll talk about later on. This is the value that this method is going to return. See that? It's going to return a type double. So if it's going to return a type double, then what I'm returning it into has to be of type double, which it is. So that has to match as well. All right, so there's my return type. This is the name, much like a variable name, right? And I've got two different implementations of this. One is a void function, and the other one is, this one is a value returning function. Okay, it takes two arguments of what type? Of double. Again, if it's expecting these two, if it's expecting two arguments of type double, then what I'm passing in up here has to be two arguments of type double. They have to match. Okay, so now I've got these arguments that are local to this method, two doubles, len and wid, and I always use different names because they're different variables. I mean, you could use the same name, but they would still be different variables, so it's just as easy to change it a little bit. It's less confusing. So what you see here is the return statement. If it is a value returning method, as this one is, see the type double, then I have to have a return statement in there. You just have to have it. And that tells execution to take whatever's in these parens here and throw it back up here. Now, when execution jumps back up here after this is executed, and the code execution was paused here and goes down here and does its thing, comes back, I now have a value over here on the right side of this thing. So in your mind's eye, you can just strike a line through this and write whatever the value is that was passed back here. But we're not finished yet. This assignment has yet to take place because it was waiting on the return of this method and a value to be put back in here on the right side of this assignment operation. So let's just say for talking purposes that the value was 4.0. Well, now it would have one value on the right, and it could take that value on the right through the assignment operation and place it in the memory location pointed to by the name on the left. So what would now be the value of double area? 4.0. All right. So let's run that, and then we'll get into the second part here in just a minute, which is a void method. All right, let's run it. See what we get here. It's going to take it a minute to fire up, apparently. Build started. Why is this taking so long? There it goes, finally. Well, it's getting there. I could pause it if I knew how, but I don't. So you'll just have to fast forward through it, I guess. There it is. Okay. Methods. All right, there's my form name. Notice it's the center screen. Focus is on the length text box. So I'm just going to put 2.0 and then 2.0. I hit my calculate button and let's see what happens. Okay, there's my breakpoint. Notice that I've got double length and double width. Took the text. What data type is a text property of a text box or a label? It's of type string. These are doubles. I'm going to have to convert those to numbers. So in this case, I'm using convert.toDouble. So I want to take the string, convert it to a double, and stick it in a double, which is what we've done here. I got 2 and 2. And then it's coming down here and it's pausing or breaking where I have the breakpoint. Notice it's passing copies of these in, 2 and 2. Execution is going to jump down to the actual implementation. Notice Lin and Wid, they now have what? 2 and 2. They're copies. That's all they are. Add those in here. Okay, so we're going to multiply 2 times 2, which is going to give us what? 4. And then we're going to return that, and execution will jump back up here because it has to. This assignment operation is not completed yet. So let's see what happens when I press F11. Okay, jumps back up to the calling location. And it's on the same line, which means that it's not completed yet. Now I wonder if it will let me do this. If it will let me actually, it may not. I want to try to stick this in the watch window. Yep, look at, see what value is of that? That call all of a sudden has a value of 4. So essentially what we have here now is double area assignment 4.0 semicolon, which is a standard assignment. It's going to take that 4 and place it in the memory location pointed to by double area. So let me add that in real quick. All right. Notice it's still 0 because that's what I declared it as initially. This assignment has yet to take place, but it's about to. So when I hit F, you'll be pressing F10. I have to press F11 because of my, it ends the video. Notice what happened. It went to the next line of code, which is going to output, and 4 is the value stored at double area. So if you want to take a look at this, I'm using the string.format method. I'm converting double area to a string, and I'm formatting it with the C operator, and then I've got square foot. And it's going to take that, convert it to a string, concatenate the square foot onto that, and stick it in the label output.text property, which will do what? Well, it will display it. That's what it will do. So let's try it and see what happens. See that? 4 square feet. There it is. All right. So there's that one. Let's exit this. So that's how a value returning method works. Excuse me. I'm going to comment this out, and I have another call down here for the void method, which doesn't return anything. They call it a void returning method, but it's just a void method. Now notice that the call here of the functionality has no assignment operator. It's just the name and the variables, the arguments of the argument list. There's no assignment because there's nothing to return. So this one will call it, take copies of all this, jump down to here, which is this implementation here, and it will, populate these arguments with copies of what was, passed in up here, and it will take A and make an assignment. Now here's the problem with a non-returning method. There's no way to get a value back from it. Not in the same way we did with the value returning method up here using the assignment operator. So if you want to do something to one of these arguments so that you have access to it in main, you have to pass it in by reference. Now remember, by default these are passed in by value, which just means copies of the value stored in memory, and then they're gone once that method ends. But what we're doing here is we're saying, all right, these two can be passed in the default way by value, temporary copies, but I want to change this one so that it actually points to the memory location. So this would be 4, 4, but this would be a hexadecimal value that points to the memory location that this name occupies or points to. So when I get down into here, into the actual meat and potatoes of the method, I actually have access. No matter what I call it, it's the same memory location as double area because they point to the same memory location. So in essence, in all intents and purposes, they are the same, even though the name is different. They call these pointers in some languages. This is called a reference variable, but it's the same thing. Okay, so I have to have 3 arguments here because I need to pass this in so that I can affect it here, so that when I get back up here, it has picked up the new value. If I were to just pass this in by value, it wouldn't do anything. In fact, I could probably do that real quick here. Let me just take the ref off. Let's do that. And then we'd just be passing it in by value, DEVL. Okay. So when I get back up here, I'm not going to have anything because this would only pass in a temporary copy. And by default, they are temporary. So I would have to put the reference back in there to tell it to do it differently. So you have to explicitly tell it, I want to do this by reference. And the reason for that is it can get a little bit dangerous. You can get pointers to memory leaks and things of that nature. All right, I'm going to go ahead with it like this, and let's see what we get. It's got to recompile because I changed the code. All right, so I'm going to put 2 and 2. Let me go up here and make sure I got a breakpoint. I don't. Let me put one right here. Okay. All right, so now I'm going to click calculate, and here we are. It broke there. Let me get rid of all of this. All right. Let's go ahead and let's put add this to the watch. Add this to the watch, and add this to the watch. All right, now I'll press F10 to step on down into the next breakpoint, which is going to be the implementation here. Now notice this is not a value returning method. This is a void method. It doesn't return anything. So you have, instead of a data type here, you have the keyword void, and there's no return statement because there's nothing to return. All right, so len is 2, width is 2, and a, which is area up here, is 0 because that's what I initialized that. We're going to calculate the area. So I'm going to press F11 or F10, either one will work. And now A is going to be what? A is going to be 4. Let's see. You can also hover over these. A is 4. I'm going to go ahead and add it to the watch window. Execution returns back to the calling location. And now the label outputs what? Well, it's not going to output 4 because this was passed in how? By default, which is by value. It's a temporary copy. Whatever I do down here has no impact on what I'm doing here. Okay, it just doesn't. They're two different variables. So this isn't going to work. And students typically say, well, why in the world don't you just make it a value returning method and pass it back in? Well, there's 2 reasons for that. One is I wouldn't be able to, to show you the difference. And 2 is, what if you wanted to have 3 things changed that you had access up here? Well, a value returning method is only going to give you 1 value back. Of course, you can mix and match it. It doesn't really matter. I mean, I'm going to have as many arguments as I want that are by reference and some by value. It just depends. Okay, so now let's see what we get. 0 square feet. That's because this never got changed. What was done down here is done on a local variable which doesn't have any input here. So we have to go back and make it by reference, make it pass it by reference. So let me stop debugging and I'll put that back in there. And the ref keyword is what does the magic here. All right, let's try it again. Save it, run it. Now let's see if we can't get this to work. To calculate. There's the call. Okay, so it's gonna, I've got 2, 2, and 0, but this is actually gonna be, instead of a 0, it's going to actually be the hexadecimal address of this memory location. And that's what A is going to now have, which is what it's got to have in order to change the value there. All right, so let's see. Jumps down here. Two times 2 is 4. Assignment is made and placed into A, which it did before. Only this time A points to the same place in memory as double area. It's the same memory location because it's passed by reference rather than by value. So now I should get the answer calculated here, up here, because those 2 names pointed to the same memory location. So if I press F10, there's my thingy. There it is, 4 square feet. All right, so you need to understand the difference of passing by value and passing by reference. Okay, that's pretty much it. I mean, there's not that much to it. You just have to kind of get used to it. And remember that somewhere within the form, in this case now we're not doing class files, which you can have other classes that you can bring into the project and store it all in different files. You can do that. But in this case, you just have to have an implementation. And remember, I introduced the region operator to you before. So when we get into classes, this is really going to be good because there's going to be a lot of implementation, a lot of functionality that you'll want to be able to collapse. All right, well, that's pretty much the meat and the potatoes, as I said before, of Chapter 6. And hope you have a good day. See you next time.